Hello guys. So one of my cousins just won this board in a contest, so I thought of putting it into a good use. And so yeah, let's learn physics. So what we're gonna talk about? Well, I'll talk about it later. But before that, I have a question in my mind. So I have this plastic ball in my hand, and I was just wondering what are the different ways in which I can able to move this ball. Well, the simplest way, just use my hand. Throw it using my hand, or just pull it using my hand. That's one way. The second way, just drop it. Gravity. That's another way of moving this ball. Third, another moving object. So I have this sponge, and I can just throw it on this ball. You see, it moves. It moves. Another moving object. If you can get more creative, just tie a rope to this ball and connect it to an electric motor. The motor rotates, the rope is pulled up and the ball is moved. That's another way, using an electric motor. Using wind. See that? Wind. Sound. Of course, high intensity sound, they really break glasses. So high sound can really move objects. That's another way of moving it. And of course, these are all these ways. So is there a common name that I can give you to all these different ways in which I can able to move an object? A common name? And yes, there is a common name. It's called energy. Please remember that the things that I'm going to discuss, it might not be in your textbook. These definitions that I'm going to use is out of any textbook. These are all my own definitions, and this is how I define energy. It's the ability to move an object. Light is also regarded as a form of energy. So can light move this ball? Yes, it can, but not directly. You see, light has to be converted into some other form of energy. By using solar cells, light can be converted into electrical energy, and we can use electrical energy in a motor, and by getting more creative, by using a rope, we can able to move this ball after conversion. Yeah, and there are some forms of energy in the universe which is making all the galaxies and all the heavenly bodies, all the stars, move away from each other. They're moving all the galaxies apart. So we really don't know the nature of this energy, and we really don't know the origin of this energy. So the space scientists call them as the dark energy. It's moving all the planets, all the galaxies, all the stars apart in the universe. Very good. So this is what we're going to talk about. Energy. Well, the next question I have in my mind is regarding the fundamental laws of physics. Newton's three laws of physics are considered the fundamental laws in physics, and the first law says that we need a force in order to move an object and not energy. In fact, all the three laws of Newton talks about force. I'll tell you what, in short, all these three laws are. The first law says we need a force in order to move an object. The second law quantifies that force. Just like any other physical quantity has a number and a unit, the second law does the same to a force. Like for length, 5 meters, 5 is a number, meter is a unit. Mass, 5 kilograms, 5 is a number, kilogram is a unit. Time, 5 seconds, 5 is a number, second is a unit. The Newton's second law does that to the force. It quantifies it. 5 newtons. Newton, by the way, is the unit of force. 5 is a number, Newton is a unit. The third law, which is quite a famous law, it says action has an equal and opposite reaction. Here, action and reaction are forces. So all the three laws of Newton talks about force, force, and force, and not energy, energy, and energy. Reason. The two reasons. Number one, you see, when we talk about energy, it really does not have any direction. Energy does not have any direction. I can use my muscular energy in any direction, but when we talk about motions, direction becomes very important. And that's why energy is considered as a scalar quantity. It only has a magnitude value, but force is considered as a vector quantity. It has a magnitude and it also has a direction. When we talk about falling objects, we always use the term gravitational force and not gravitational energy, because it's always moving in one particular direction. All the falling objects are moving vertically downwards towards the center of the earth. The second reason is, like we discussed before, not all forms of energy can be directly converted into motion. Like light, it has to be first converted into some other forms of energy before it can move an object. So these are the two reasons. But still, question in my mind, how do we define a force? What the heck is a force? Well, I would define it. It's simply a pull or a push which is derived from energy in one particular direction. You see, force is something that we get when energy is released. It's the end product of energy. It's the energy in action. That's the best way of understanding force. It's the energy in action. So I would use this particular definition, pull or a push which is derived from an energy. You see, energy ताकत है और force जोर है. बिना ताकत के आप जोर नहीं लगा सकते. जोर लगाने के लिए आपको ताकत होना जरूरी है. So force is derived from energy in one particular direction. So all these different ways in which we can able to move an object can be deduced to a system of a pull or a push and energy. Using hands, well, I can pull or push using hand, using my muscular energy. Dropping it, it's a pull from gravitational potential energy. Another moving object, it's a push using kinetic energy of another object. Electric motor, it's a pull using electrical energy. Wind is a push using wind energy. A jet of water, it's a push using hydraulic energy. Sound, it's a push using sound energy. Okay, now let's come back to energy. Now, we discussed that energy is the ability to move an object. I will give you a scenario. You see, I have this hammer and I have this rock in my hand. Now, I'm going to move this hammer using my muscular energy, which will be converted into kinetic energy in this hammer. And, well, this kinetic energy should move this rock, but it is not moving. So, where is all the energy going? Is it dead? Is it getting destroyed? Well, one of the laws concerning energy is law of conservation of energy, which says that energy can neither be created nor be destroyed. So where is this energy going if it is not getting destroyed? Where is it going? Well, in order to answer that question, we have to think a little deeper into this object. You see, every material, every object is made up of atoms and molecules. I'll show you a simple molecule. This is a simple ethane molecule. It has 2 carbon atoms and 6 hydrogen atoms, a simple ethane molecule. But inside material, all these molecules are not like this that you're seeing right now. They're always vibrating, something like this. All the molecules are vibrating. And what is the effect of this vibration? The effect of these vibrations are temperature. The higher the temperature, the higher the vibrations. The lower the temperature, the lower the vibrations. In the case of gases, the molecules have a lot of freedom, so they don't vibrate, but they are moving really faster. And the movement really depends upon the temperature. I have an app which tells the movement of molecules inside a gas. So these are the gas molecules moving at about 10,000 kelvins. This is how they're moving. Now watch what happens when I increase the temperature. I'm just going to add another 0, make 10,000 to 100,000 Kelvin. I'm just going to make it 100,000 Kelvin. Now see what happens. Now they're moving much faster. The higher the temperature, the greater will be the movement. So this is the effect of temperature. So in our case, this hammer is not physically moving the rock, but it is moving something internal of the rock. It is making the molecules vibrate much more faster. This is a everyday experience. If you hit the hammer on the head of a nail and you just touch the nail after 3 or 4 blows, you will see that the nail will get heated up. That blow is being converted into heat, and that's what energy can do. It can also heat an object. This is going to modify our definition of energy. Number 1, energy is the ability to move an object. Number 2 is the ability to heat an object. What else? Now watch what happens to this plastic ball. You see, I'm using my muscular energy. It's not moving, it's not getting heated up, but its shape is changing. And that's another thing energy can do. It can change the shape of objects. And that's number 3 in our definition. Energy is the ability to deform an object. Well, all these deformations, when energy will be reduced to force will be used in most of the calculations in deformations, and it's a huge branch of engineering called the strength of materials. Let's not get into that. But if you look very carefully, all the 3 definition of energy that I've just put down, everything is linked to movement. Move an object is clear physical movement. Heat an object is an internal movement. Deformity in an object is changing the structure of the molecules. It's again movement. So everything is connected to movement. This is just for the sake of understanding. I've used first energy and then I try to explain the force, but in reality it's force that was first introduced by Isaac Newton, and it was his theories, his laws were dominating the world of physics. It was much later, maybe after 2.5 centuries, the concept of energy was first introduced. But for the sake of our understanding, I first used energy and then I try to explain force. And if you're writing an examination, please stick to your textbook definitions. These are not the definitions in any textbook. This is purely for the sake of understanding. And this is really one of the flaws in our education system, where we are not encouraged to think out of the box and come up with our own definitions. We are taught to always stick to the textbook definitions, and we are taught always to write the textbook definition in examination. So if you have to write what is energy in an examination, please write it's the ability to do work. Actually, such definitions really make things really complicated, because work is again defined as force times displacement, and force is defined as mass times acceleration. It's really confusing. If you are asked to write what is force in an examination, please write force is the rate of change of momentum, and the direction of force is the direction of change in momentum, and momentum is mass times velocity. You see, every definition is leading to some other definition. Things are not, that clear according to me. So this is purely for the sake of understanding. Okay, so when we talk about energy, there are 2 physical quantities again that we always talk about with it, and these are work and power. What are these? Well, energy is making things move. Work is how much the things have moved. I can move this object through this distance, and I can move this through this distance. This is less work, this is more work. Work is force times distance. Power is how fast the things are moving. You see, I can move this ball like this. I can move this like this. This is less powerful, this is more powerful. Actually, many definitions of power that you can find. One of the definitions says power is work done per time taken. One definition that we used is force times velocity. Another definition of power is the rate of energy conversion. You see, all the scenarios that we talked about, another way of looking at it is energy conversion. Movement is actually kinetic energy. So all this wind, sound, and my hands and all the different forms of energy is actually being converted into kinetic energy. And how fast the things are being converted is power. But one thing that is very common in all these definitions, time, velocity, and rate, is speed. And that should come to your mind immediately when you hear about power. Speed. Power. Boom. Speed. So when you hear the term energy, the first thing that should click your mind is movement. When you hear about force, the first thing that should click your mind is pull or a push. Work, first thing that should click your mind is distance. Power, first thing that should click your mind is speed. Talk about the units of the physical quantities. Well, work is also termed as useful energy, and work and energy have the same units. It's called joules, after the famous physicist James Joule, who worked extensively on energy conversions. The unit of force is Newton, after the great Isaac Newton, who worked extensively on motions and forces. The unit of power is watt, after a Scottish inventor, James Watt, who worked extensively on power machines. So that is all about energy, force, work, and power. Hope this video is helpful. Thank you very much.